What's going on, guys? So today we're going to be going over the lab number 4 DaNI Robot tutorial. This is for group 12 in the Intro to Robotics course. My name is Joseph Anderson. My other two group members are Shapur Shiraz and Lindsay Ward. So the robot we picked to work with today is going to be our buddy Agent Smith over here. He seems to be in functioning word, and everything seems to be working okay. He's even blinking at you just to let you know he wants to say hi. So the first thing we're going to do is come over to our lab view diagram, and we are going to flash our code. Zing, there that goes. So we're nice and flash. The code is ready to run. So now that we're running, we're going to test the accelerometer. First thing we're going to test is that accelerometer. So as you can see, nothing's happening, but time is moving. That's because he is stationary. So as we do like such, take him out of this wheel here and just kind of move him up and down a little bit. You'll notice on the graph that accelerometer is working perfectly as it starts to plot those up and down movements there again. Okay, so the second thing we're going to be testing today are the encoders on the wheels. Those encoders are basically just to count the number of rotations and or like the value of the rotations going on. So now that it's orange, we're testing. So as you can see, when there's no wheel motion whatsoever, there's no motion here, so it's not counting anything. But if I spin the wheel as such, we should see that right number go up, and then we can actually go back down as I turn the other direction. Yep, now we're in the negatives, and now we're going back positive. So that's working very well. Okay, so really fast, before I get into this too deeply, I'm going to go overhead and show you guys the programming behind this wonderful robot. So, for the most part, it's literally one giant while loop with a control case here. Control case being the different settings and different testing that you can do. So what this guy is actually a flat sequence frame, basically just telling it do this first and then do whatever's in this guy. So the first one is your accelerometer testing. It's pretty simple. Just calls the the VI that's already saved in the total test VI encoder. Same thing, has your counters and everything like that. IR, same thing. Motors, same thing. Ping, servo. Servo is the same thing. Your ping is a little bit different. So the ping actually has to call a whole separate function, which is in this disabled loop box here, but we can get rid of that for that ping test, which is exactly what we're going to do. Alright, so the third thing we're going to be testing today is going to be our IR sensors. They are mounted here on the bottom side of these L brackets. The idea being that they are there to detect and help the robotic system avoid a cataclysmic drop of some sort. So the way that works, you hit test. As you can see, the values are pretty low, between 1 and 2-ish. But that is also because it's pointed off the table and at the ground. So if we back this guy up, back up onto the table like that, we'll notice now that our voltages are up in the 3-4-ish range. And if you put my hand underneath as such, you'll see that one of them actually goes up to the higher 3s and even into the 4s instead of just 3. The basic idea is that it's a proximity sensor, so that it knows if something's too high, it will stop the robot and stop the program. Yep, and it seems to be working just fine. Now for a fun part of the testing, we're going to test the motors. So, as you can see, our motor values are currently at 0 and the test is not running. That being said, he is also sitting here, stationary on my desk here, so he is not moving any place. So, we're going to start the test with 0 value, and as expected, no movement is occurring. Now, we're going to crank up our values here to 50 and 50, and I don't know if you can hear that, you probably can, but something just started moving. So as you can see, we have our little right wheel there moving and our left wheel moving. Now if you'll notice, they're both running clockwise. You can see the rotation going from left to right across your screen, and here again, left to right across your screen. So what that means is if you actually were to put it on the ground, it would be spinning in a circle. So we gotta fix that, right? So what we're going to do is we're going to come on here and put this guy at -50. And now he'll go in a straight line. So as I said, we shifted our motors here to -50 and 50. And I've also shifted our boy from the counter to the ground so we can move him around and drive him around a little bit. So we're going to hit test and see what happens. And look at that. There he goes. So what I'm going to do as we're doing this, let's say I want to turn right. So we're going to turn this right throttle down a little bit, and there he goes, turning right. He's gonna come on back to me. Come on, you can do it, bud. All right, and now we're going to come straight. Oh, a little fast. Okay, we're not so good at going straight at the moment, but he's running. He's a good boy. Okay, so for this last test, you do have to do a little bit of extra work. So when you are looking at your lab view, you can pull up your block diagram, which is what we're looking at here. And so what you have to do is come to this disabled loop down here. You can right click it and you can see remove diagram disable, enabling this other function outside of the lab view to be able to run so that we can run our scan function. And we're going to save all using Control-Shift-S, hit run. It's gonna go and flash, and it's flashing. There it goes. Okay, we're gone. So now that we're flashed, we're gonna come back to our lab view. The testing VI, we're going to start our servo test, and then we're going to start our ping test. And as you can see, our dial's all the way to the max. But when I pick my hand up just like that in front of it, it moves. So depending on how far I put my hand from the thing, get close. Alright, so as I said, if you get this guy nice and close, you'll see that our value goes down there because we're holding a piece of paper up to our sensor right next to the robot eyes. So as we back it up, we'll put it here about the mid table, about a foot away. Hey, look at that. It's about a foot away. So that's how that works. It's basically just a bump avoidance or object avoidance kind of software. Has pretty good uses there. Anyways, but yeah, that's our DaNI Robot. That's group 12. That is, again, me, Joseph Anderson, Lindsay Ward, and the man, Shah Shapoor. Alright guys, peace. Alright, so now that the fun part's over, we're back to testing other things. So we're going to test the IR sensor. I'm sorry, not the IR sensor. I meant the servo that's holding our ultrasonic sensor. It's a proximity thing. So as you can see here on our screen, we have the number of scans, which is the number of times that our servo is going to move. That servo being right here, as I said, underneath our ultrasonic sensor. So now that we're testing, we're going to go up 1, 2, 3, and we're going to see what happens. So if you notice, there's three movements actually, 1, 2, 3, and scan 1, scan 2, scan 3. So now we're going to go up to a little bit higher, 10. So now it's going to be a little bit more jittery, but it's taking 10 scans as it turns from one side to the other. The maximum number here is 20, which is almost fluid motion and almost continuous scanning. This would probably be the best way to do it if you were really concerned with the proximity or location.